Yes, done fractions and then done posted under February 1st. Due yesterday. If you don't have that done, please get that turned in. Decimals quiz.
February 5th.
Is posted today under February 1st. Due the end of class tomorrow. Make sure you get that downloaded. Try to get done in time today to give you a little time to work on that quiz or to work on other quizzes. Now, something I want to make sure I repeat, I mentioned it before, but I want to repeat it here at the beginning of class when if people are watching the recording, they're still paying attention. Is a test correction. So on your quiz, on your tests, you can redo the problems you got wrong. To do that, you have to show all your work on the problem. You can either do it, if there's room, you can do it right on the page of the quiz or test. Otherwise, you can attach a separate sheet of paper to it with your work so you've got room to work it out. If you do that, I ask that you try to staple it to the original quiz so I know which quiz it is, or make sure you clearly label, at least on top, what quiz it is so I know that. Do that, you get up to half your points back. So let's say you had a 76 on this last unit test. You do all your corrections, that brings you up to an 88. And you can work with anybody you want to if you need to. But you can talk to classmates, you can have family or friends help you out, you can have me help you. I will sit down and work through it with you at the end of class if we have time to make sure you have more. You can go to our tutoring center and have somebody there help you. When you turn those in, make sure you are very, very sure of your answers to get back as many points as possible. There's two purposes to those. One is, the main purpose is I want to make sure you've done the problems correctly and you have the correct process and the correct answer on paper so you can go back and look at it later if you need to. And the second is to get you as many points as possible so you guys can get. If you have any questions on corrections, let me know and I will help you out with it. Today's class actually is going to be a little bit of a shorter one, so we should have some time to go over some quiz questions. So today we're going to go on to the next logical step after decimal. That's percents. Now, percents is a smaller case. It's an application of a larger topic called ratio and proportion. Ratio is a comparison of two numbers. Like you might hear them say, 3 out of 5 people prefer this product over others or whatever. That's a ratio. Percent is a form of a ratio. It's just a standardized form. So to understand how percents work, we first have to understand the word percent. And it's actually two words. Per, if you think of miles per hour, dollars per hour, miles per gallon, for each or out of. Then cent, think of years in a century, cents in a dollar, 100. So the term percent means out of 100. So if I have 68%, that literally means 68 out of 100. Now, one of the things we need to be able to do with our percents is to convert them from one form to another. One of the things we might be asked to do is to convert a fraction. That's the phraseology, the wording that is typically used, even though it's not really a fraction. It's really a ratio, like this. but they call it convert to a fraction or fraction form. So we'll use the term fraction form. Again, it's just a ratio is what it is. It's not truly a fraction. So in this 68 out of 100, that is in a fractional form, but we would typically want to reduce it. Both 68 and 100 can be divided by what number? Be divided by 2. 68 divided by 2 is
34.
34, and 100 divided by 2 is 50. Are we done?
No.
No, both of those can still be divided by 2 again. 34 divided by 2 is 17, and 25 divided by 2, or 50 divided by 2 is 25. Kind of gave that one away. That's as far as we can go, 17 over 25. So that's not really 17 25ths. It's not a fraction, it's a ratio. That's saying 17 out of 25. If I have something like 45%, I want to convert that into fractional form. Well, percent means out of 100. So it's 45 out of 100. What am I going to do to that? 5 by 5. What will that give me?
9 over 20.
9 over 20. Good. 45 divided by 5 is 9. 100 divided by 5 is 20. So that's 9 out of 20 is the fractional form of 45%. I might have 360%. Now, first thing you'll notice, that's large. I mean, it's really large. 100% is equal to one whole thing. The whole object, we're going to call it. 360% is bigger than 100%. So it is actually more than one. It's more than a whole thing. But when we convert it into fractional form, we're still just going to do 160, 100. Now, both of those can be reduced, but it's also an improper fraction. This would be the easiest place to convert it into a mixed number because dividing by 100 is easy to do. You can figure out how many times and what's left over. 100 goes into 360 how many times? 3. And how much is left over? 60. So that's 3 and 60 hundredths. Now we can reduce that. Both 60 and 100 can be divided by 10. That's 6 over 10. Don't forget the 3. But it can still be reduced by 2. 6 divided by 2 is 3, and 10 divided by 2? 5. And notice I left space. You still need our whole number of 3. So it's 3 and 3/5 is what that percent is. We might have 36 2/3%. Yes, I know. It still means 36 2/3 out of 100. But we don't like having fractions within our fraction. There's 2 ways we can deal with this. One would be to come up with a least common denominator treat it as 2 separate numbers, which it is in this case. It's not. It's a ratio, so it is comparing 2 numbers. The least common denominator, well, the only denominator there is 3. So the least common denominator would be 3. Multiply each of those 2 numbers by 3, and it'll get rid of the fraction. 36 2/3 divided by 3, well, that is, I have to make it an improper fraction. 36 times 3, 108 plus 2, that's 110 thirds, times, if we multiply by a whole number, it's 3 over 1. We can cross cancel the 3's. 1 and 1, right? What happened? That's right, I get 110 there on top. On bottom, 100 times 3 is 300. Now, both of those now, I have a fraction without other fractions in it, but both of those numbers can be divided by 10. You give me 11 over 30. 110 divided by 10 is 11. 300 divided by 10 is 3. So 36 2/3% is the same as 11 out of 30. That ratio. 56.25%. That again is 56.25 out of 100. Now we don't like having decimals in our fractions any more than we like having other fractions within our fraction. So we want to get rid of that decimal. To do that, we look at the number of decimal places. How many decimal places are there in this number? 2. Get rid of 2 decimal places, we have to multiply by 100. If there was 1 decimal place, multiplying by 10 would do it. 2 is 100, 3 would be 1,000. Just like with moving our decimal over when we did division with decimals yesterday. So I'm going to multiply by 100 here. I have to multiply the other number by 100 as well. 56.25 times 100 is 5,625. 100 times 100 is 10,000. Now we have some ginormous numbers here that we're going to have to reduce. What can both of those be divided by? I see 5, but I can see 25 also. Give us a little bit of time. 5,625 divided by 25 is 220. 10,000 divided by 25 is 400. They can both still be divided by 5 or 25. There you go. 225 divided by 5 is, or 25 is 9. 400 divided by 25 is 56.25% is 9 out of 16. Any questions there?
I don't like when you have, when you turn a fraction, or not a fraction, but a percent into a decimal.
Percent into a decimal?
Yeah. Don't you just move the decimal place 2 spots
Yeah,
over?
but let me show you why that is. That's actually our next step here.
That doesn't, never made sense to me.
We've been asked convert to a decimal. First of all, it's not really a decimal. But it's really saying it's decimal form. What it really is we're converting it into a rate. More specifically, unit rate. Unit rate means out of 1, for every 1. 68% means 68 out of 100, right? A decimal or a rate is the more accurate name for it. Means out of 1. 68 out of 100, well, how many out of each 1 would that be? Well, to turn the 100 into a 1, we divide by 100. What do we have to do to the 68? We have to divide by 100. Dividing by 100 just takes the decimal point, which would be at the end of the number since it's not written, and moves it over 2 spots. That makes it 0.68. That's 0.68 out of 1, or just 0.68, is the decimal form, or the rate for that percent. And so when they say convert to a decimal, what they really mean is convert it to a rate. And a rate is going to be in decimal form. It looks like a decimal. So if we have something like 71%, that's 71 out of 100. How many will that be out of 1?
0.71.
Divide by 100 or move the decimal over, 0.71. If we have 3%, divide by 100 or move the decimal over 2 spots. Oops, I got 1. I got to fill in a 0, don't I? 0.03. If I have 480%, what's that going to become? 4.8. Good. I have to divide by 100, move the decimal over 2 spots. 4.8. If I have 7.6%, what's that going to become as a rate? 0.076. Good. I have to move it over 2 spots. That's 1. I have to add a 0 to go 2, so 0.076. Here's the one people typically get incorrect. 1/4%. Turn that into a rate. Well, That's usually the answer people give at first, 0.25. That is still a percent. This is just a fractional percent. This is a decimal percent. You get it into decimal form or into a rate, I still have to use
0.0025.
There you go. Good call. You still have to divide by 100. 0.0025. Check that, or to deal with that, what I use is something called benchmarks. Benchmarks are common numbers, common percents, that are easy to calculate. 1% is one of those. What would be the rate or the decimal form of 1%? 0.01. Perfect. 1/4% is that smaller or larger than 1%? Smaller. So its rate has to be smaller. So if we get the 0.25, that's bigger than the rate for 1%. 0.0025 makes sense. Going the other direction now, going from a rate, remember a rate is just the decimal form, back to a percent. By the way, I've used the word percents a couple of times in this lecture. That's technically not even a word. Percent. There's no plural form of percent. It's just percent.
Here. Like, there's no plural word for moose or deer.
Deer. I saw several deers in my field last night.
I thought I saw several moose and the other day.
Moosin or a meese. Oh, 0.29 is a rate. Remember, that really means 0.29 out of every one. Turn it into a percent, it has to be out of 100. So, to do that conversion, turn the 1 into 100, I have to multiply by 100. So I have to multiply the 0.29 by 100 as well. 0.29 times 100 is 29. That's 29 out of 100, or otherwise known as 29%. So each time when we convert that decimal form or that rate into a percent, it's going to have to be multiplied by 100. So all we're going to do is move the decimal point back the other direction. So if I have a rate of 0.79, what's that going to become?
9%.
Move it 2 spots, yes, 79%. If I have a rate of 0.4, what's that become as a percent?
40%.
Good, we go 1 spot, we have to have a 0 to go a second spot, that is 40%. If I have a rate of 3.7, what's that become as a percent? 370. We still have to go 2 spots. We go 1, have to add a 0 to go a second spot, 370%. Or 0.082, what's that become as a percent?
8.2%.
Perfect. We go 2 spots, that is 8.2%. Finally, we have the conversion from fraction back to a percent. To do that, let's start off with one that most of us know. 3/4, what percent is that? So that's 75%. So let's look at it. If we didn't know that that was 75%, that's one way we could do it. We could turn 3/4 into a decimal. 3 divided by 4, which makes 75. Then we'd multiply by 100, move the decimal point over to 75%. But we could also just treat that, it's a ratio. Remember, it's not truly a fraction, it's a ratio. That's 3 out of 4. Well, how many would that be out of 100? Because a percent is out of 100. Now here it's pretty simple. We can see that 4 has to be multiplied by 25. So 3 times 25 is 75. So 75 out of 100, otherwise known as 10. Not all of them are quite that simple. Haven't learned by now? I always make it worse. My job. 5/8, 5 out of 8. If we want to turn that into a percent, we know how many is that out of 100. Well, looking at this, we can't see right away what you can multiply 8 by to turn it into 100. But if we have to, we can work backwards. Instead of saying, what do we multiply 8 by to make 100, we can go 100 divided by 8. Remember, we said that problem, blank times 8 equals 100, is equivalent to division problem, 100 divided by 8 equals blank. Remember that? Back in our integers?
Yep.
So this is the number. That's the number that 8 is multiplied by, is 100 divided by 8. That's what we multiply the 8 by to get 100. So that's what we're going to multiply our top number by. Now I wrote the whole thing out rather than dividing it out to get a number for that, because it shows a pattern here. I can actually remove the parentheses there and it does not affect this answer. Take that 5 times 100 divided by 8. When we have this setup, this is called a proportion. And to work with a proportion, we have 3 known numbers and 1 missing number.
Oh my gosh.
There's our missing number. In a proportion, there's always 2 numbers that are diagonal with each other. That's the 5 and 100. Notice it's 5 times 100. Those 2 numbers that are diagonal with each other get multiplied. There's another number that's diagonal with the missing number. That 8, we're going to end up dividing by. So to solve this, it is 5 times 100. They're diagonal. That's 500. Divided by the 8 gives us 5. 62.5 out of 100, or sounds like a major revelation over there.
I just came back to me.
Okay, good. So we might have something like 5/7. As a 5 out of 7 is a ratio or a fractional form. If I want to turn that into a percent, I'm asking how many is that out of 100? What am I going to do to find that? 2 numbers that are diagonal with each other are the 5 and 100. So 5 times 100 is 500. Number that's diagonal with our missing number is the 7. So we divide by 7. That's going to give us 71.42857,143 approximately.
I believe you.
Rounded off, we'll call that 71.43. Out of 100, or 71.43%. Not so bad? Better sharp stick in the eye?
I'd say a tuning fork.
Tuning fork? Vibrating or calm?
Vibrating.
Okay. Now the next step is to start calculating with these. That's what we're going to do tomorrow's class, is actually start doing calculations. For right now, I want to mention more about that benchmarks that I brought up earlier. Let's say I have the number 8,400. That is my full amount. That is 100%. 100% is what is referred to as our base amount. It is our main value, the value that we're starting with. It's the value that all of our other calculations are based off of. That's why it's called the base amount. Well, if I want to find smaller percents, let's look at 10%. Well, 10% means 10 out of 100, which can be reduced to 1/10. How do I find 1/10 of something? Take away a 0 or move the decimal point. 8,400, 1/10 of that, I just moved the decimal point over. That's 840 is 10% of 8,400. 1% is another fairly easy benchmark. 1%, of course, is 1 out of 100. To find 1/100th of something, 1/100th of something, we decimal 2 spots. 1, 2, that's 84. So if I'm doing other calculations with this, let's say I ask you to find let's do this. Let's say find 12% of 8,400. Well, we know that 10% is 840. So does 12% have to be larger or smaller than that?
Larger.
It has to be larger. So we know right away that 12% has to be something smaller than 840. We can find the 10% quickly, and we can use that to compare. Now we can actually go even further than that here. I can say that 12% is 10% plus 1% plus another 1%. That would be 12%, right? And we can use those benchmarks. We can easily see that 10% is 840. 1% is how much? 84. And the other 1% is also 84. If I add that up, I've got 8, 16, so 0, carry the 2. 12% is 1,008. 12% of 840 is 1,008. By just adding up those simple benchmark percents. I asked you to find 19% of 3,100. I can find a way I can rate 19 as some of my benchmarks. I have 10% plus another 10% and then minus 1%. That would give me 10 plus 10 is 20, minus 1 is 19%. Well, what is 10% of 3,100? 10% is still 310. 1% is 31. I want to put that in red because I'm going to subtract that. 310 plus 310 is 620. Minus 31 is 589. 19% of 3,100 is just 589. So I'm able to put together those benchmarks to find they're simple percents, they're whole number percents, but still, at the very least, I can use them to double check. I know that 19%, 10% is 310, double that 620, so I know that 19% has got to be a little bit less than 620. Make sense? So tomorrow we're going to look at actually formally doing calculations with percent. So in fact, we're going to spend the next few classes looking over calculations with percent. Talk about investment, interest. I'm going to get up on my soapbox a little bit early next week and talk about saving for retirement, just because age is key when you're
Already got a couple of
started. The difference between starting at 21 and starting at 31 is just incredible.
It's insane.
Yeah. So we'll go over that stuff probably Monday and Tuesday. We'll look at those things.
High yield savings account.
Yeah. Difference between investing at even finding CDs or savings bonds at like 6% compared to getting into mutual funds that'll give you 8 to 12%. Huge difference in your return. We'll look at all that as well. Your homework, page 79 through 80. 1 through 81 the odd. And as always, again, feel free to do a couple of easy ones and skip ahead to the more difficult ones if you seem really easy. Anybody have any questions on these? Okay, well, don't forget there is that quiz out there. If you have not completed the quiz from Monday yet, That I believe is quiz 3 from Monday, from February 1st. Make sure you get that submitted. And quiz 4 is our decimals quiz that's out there for today. That done in submitted for February 3rd. You know, some
Like 11 days from. Okay.
So you guys have the rest of the time here to get started on homework. I'll be here to answer questions. Otherwise, if you